CTW Automation here, and in this video we're going to work through the test sequence, the structure for building a test in the software we use for our linear actuators, the LA and any RORG EMAs that we upgrade. So we're going to do a series of these videos starting from basic to get more advanced, more explanation, and really show you how everything needs to be. Now, from the simplest to the most complex test in LA, we always need to remember a few things. And we'll work through these as we go, but the first thing you always need to do is to have an enable axis at the beginning and a disable at the end. Always, no matter how long or short the test is. You always have to have a start recording and a stop recording. This is the information. Anything between these two is what you'll be able to see, to view, to look at. And then you have to have a push gain, which is a more performance-based gain. That means the actuator is going to move basically with a stronger motion control. And then a pop gain, which takes it back to a very gentle, basically a move to gain, where there's no real performance, it's just getting from one spot to another. And then you're going to have some form of either 1 test speed, 5, could be 10 or 20 even, but somewhere in here between the start and stop recording, we're going to do our test speed. So that is the basic outline of every test that you're going to make in the LA software. And now that you know that, we're going to actually build a test. Now, I had one pre-done here, but I'm going to start from the beginning. So I'm going to clear this, and just so you know, here's the outline of the basic software. It looks a lot like the crank, you just have more features in the LA version of it. We're still going to use Test Builder just like all our other versions, and we're going to use the commands to build this test. So you get to build the sequence to do anything you want. To get a little more screen, I'm going to do auto hide, and you can do that on any of those windows just by hitting that little button. That way we can see as much information as we want. So we're going to start by clearing, and we're going to build our sequence. These commands get loaded every time you click on one. So, as I said, we're going to do an enable axis right there. Now you get an error because we haven't disabled. Well, that'll go away when we're done. So, enable axis. That basically means the actuator is now active. Doesn't mean it moves, it's just active. It's sitting at bottom. We call that either home or 0. So basically, very BDC. Now the first thing we always want to do in any of our tests is do some kind of a warm-up. Get the damper moving before we start to collect data. Sounds good. You want to make sure it does move. You get the fluid going and reach some state of harmony there. So enable axis. First thing we want to do is move the actuator up off of 0. So we do that by using the move to position. Click on move to position, it loads over here. If you click on this, you get your move to. Now everything's absolute, so that's from 0. So let's just say we're going to move up 1/2 of an inch. So that means the actuator, when it gets to this command, is going to move up at 1/2 an inch per second, or move up 1/2 of an inch, 12.5 millimeters, and you tell it the speed to move. You want to typically move slow. You don't want to do anything fast. In this, you're just trying to get it into position to do the next command, whatever that may be. Now, I said we're going to do some kind of a warm-up. We have two choices. We have a temperature-based warm-up, and we have a timed. They should be self-explanatory, to be honest with you, and I'll show you what they are. So the temperature warm-up actually warms the damper till it reaches a temperature. The timed warm-up runs to a specific time. So we go back to temperature. Basically, the linear actuator, you can give it a positive amplitude and a negative amplitude, compression and extension from a mid-stroke, a midpoint of the run, a speed to run at, and basically a target temperature. I think typically we do a lot of 90 degrees. You get to decide how hot you want it to get, but this is the way you do your temperature-based warm-up. I'm going to get rid of that. Just use the X. We're going to use the time-based warm-up. So we're going to run 5 seconds. Run 10 seconds just for grins. So we're going to run for 10 seconds, and we're going to put in a temperature, and this is actually a maximum. So if it runs for 10 seconds or any time less and it sees a temperature, it will proceed to the next step. Kind of like a protection. So you want to be careful this isn't set too low, because it may just go off immediately based on the temperature of the damper. Again, a positive and a negative amplitude. You add the amplitudes together and you get the stroke. So this is going to be a 1-inch, a 2-inch stroke, 1 inch up, 1 inch down, basically from midpoint. Run for 10 seconds at 10 inches per second, and you can make that whatever you want. So there's your time warm-up. Once it's done, once again, we want to tell the machine what to do next. So when it's done with this command, we're going to say move to position so we can do our test, and we'll actually leave it at 1 inch. Leave the speed, that's fine. So basically the actuator is going to go from here, and it won't update until I save it, but that's a 1/2 inch, and this is 1 inch, and we're gonna start our test from here. Now everything is absolute, so that is 1 inch from the bottom of the actuator, for where it sits at rest, up 1 inch. So once that is done, we're going to go ahead and start recording. Everything after this is going to be recorded for you so that you can see it. You can use it, you can look at the data and graph, print, do reports, etc. But the start recording, stop recording is how that operates. So we're going to start recording. Now, for the simple test, we could do start recording and add 2 test speeds. We could do nice and simple 2-inch stroke. We could run at 5 and 5, and you can see you can type these in by hand, or you can just use the pull down. And we're going to run 2 cycles and pick the second cycle to run. We'll come here, we'll run this at 10 inches and 10 inches. Same 1 inch stroke, or 1 inch amplitude, 2-inch stroke. We'll set that. Only need to run 2 cycles and select the second one. So quickly we have a 5-inch and a 10-inch per second speed. And as I've already forgotten, that after start recording we want to do the gains. Going to add the push gain, and that way you can see. So I've added it in the wrong spot. If I grab it with the mouse and hold, I can drag it up, and when that bar, wherever that bar shows up, that's where it's going to go. If that bar is not visible and you drop it, it's just going to go back to where it was, but that bar is what says where it should go. Now these push gains are basically a stronger performance type gain. Now the gains, simple way to look at this is it's basically how hard we tell the actuator to move. And there's a long list of parameters that basically tell the actuator how to move, what to follow, basically displacements and velocities and accelerations, and if it gets off track, how hard to get back, how quickly to get back into position. So the actuator is nothing but a big electric motor, and it's basically how hard we drive that motor to follow the command we've given it. So these push gains are the harder, more performance type gains, and when you click on it, they're going to load into this default. This default is very soft, and we are going to go, you can use your manual, you can use our guidelines, but the idea is we like to have this KP between 1,000 to 1,400, and this KPAUSE, I click down in here, anywhere between 100 to 150. Now these will get you, should get you everything you need. If they don't and you want to talk to us, we can certainly help you develop gains a little further, but basically these are the iterations, the PID loops is what they're technically called, of how hard the actuator is going to follow the command that it's given. And if you get out of range, you get some of these numbers too high, you will cause some squealing, you will cause some problems, and we are trying to avoid that. So that is the push gain. And we have our run test speeds. We've run 2 speeds, And we're going ahead and getting back to this. Push gain, you run your test speeds. You're going to do our pop gain, stop recording. So we're going to come over here and we do pop gains. Now, good question. So the push is the hard gain. Pop is the softer move to gains. Now you see when you click on pop gains, there's nothing here. Push gains, you can change. You can add push gains and change it. Pop gains, they are stored in configuration as permanent. So if I click on this configuration tab over here, you see it comes out. These gains are what are called up when you do pop gains. You notice everything is soft. I went up to 1,000 on my push. This is down at 550, nice and soft just for moving. So that's what the pop gains are. So basically, if you think about it, these are our performance gains we're applying to the test, and then we're taking them back down to a softer pop gain. Once you have that, you can stop recording, and that ends the test. So everything in here you will have access to. Stop recording, and then we will move to 0, and that means go back home. Take the actuator back to that home position, that bottom position, that starting position that we had just before we enabled it. And of course, we disable the access. You see all the errors go away and the test sequence is happy, and you have a nice simple little test. And once that's done, we do save as, and as you can see, the beauty with CTW Probe is you can actually give individual test files names, and you can use them, send them to perhaps other people in your company, but these are actual tests, kind of like a Word document. They're individual, and you can use them however you would like. So give it a file name. For this test, again, nice and simple, but this is just video test demo A. Nice and simple test. Now that, like I said, that is a test that you could send to somebody. If you had more than one machine, all the tests you make, you can just put them, say, on a server, and they can download them onto their computer, and you only ever have to create the test one time. But that is a simple test for an LA, and let you look through that, let you get see what you think, and join us for the next video where we're going to expand on this and make an even longer test and get more in depth about things you can do with your software and your actuator. There you go. See you soon.